colleagues. Today we are honored to have with us a globally renowned speaker, a very renowned figure among the Indian industry, Mr. Ravi Kumar Yalanki. Now, Mr. Ravi is having a professional experience of more than 25 years, mostly concerning about the hatchery operations in India. I mean the litopinius venoming hatchery operations in India. Mr. Ravi has been instrumental in introduction of SPF broodstock in the country. Mr. Ravi's hatchery, Vasaki Biomarine, the group with which he is associated with, is the first hatchery to pack the seed of, we can say, SPF seed of Litopenius venoming. He is bringing with him a rich experience in terms of shrimp farming, shrimp market analysis, hatchery seed production, shrimp seed production. He has contributed through not only his expertise in terms of shrimp, but also through his numerous publications. He has shared his experience, knowledge globally, worldwide, that regarding the shrimp hatchery sphere, such as management and its role in changing environment. He is an expertise in terms of shrimp market trends and opportunities. Mr. Ravi has been the past president of Society of Aquaculture Professionals. I think all of you are very well aware of the Society of Aquaculture Professionals. And he has been secretary, former secretary of All India Shrimp Hatcheries Association. He is associated with Vasaki Biomarine, which is a leading group in shrimp hatchery operations in India, which is operating pan-India. Now, they are extensively involved in production of good quality, robust SPF and SPR seed. So, Mr. Ravi, we welcome and we are blessed to have you with us today as a speaker. I am pretty sure that our students will be highly benefited with your lecture. As I know, you are a wonderful speaker. I had the opportunity to listen to you couple of times. Once during the shrimp school in Vijayawada, and also through YouTube and many other social media platforms. I know you are a globally renowned speaker. And I welcome you to today's webinar. We have my colleagues with us. We have Dr. Jitendra Kumar, Dr. Shantana Goda. They are my colleagues and coordinators for today's webinar. We have Mrs. Amandeep Kaur. She is a senior research fellow in IDV project. We have basically, Mr. Ravi, let me tell you, we have a very renowned project which is being sanctioned by Indian Council of Agriculture Research, ICR. So that is IDP, Institutional Development Project under NAHIP, National Agriculture Higher Education Project, basically. So we are taking various initiatives. So this is one of the initiatives that we are organizing series of webinars for our students, because amid this COVID, our students, we cannot take our students to the countries and they are away from us. They are not physically here, they are at their places. So this is an initiative thanks to our Vice Chancellor, worthy Vice Chancellor, for this kind of advocating us to organize this kind of seminar. So over to you, Ravi, please.
Thanks, Professor Prabhajit. Thanks for all the kind words. and good morning to all the participants, your colleagues, students, and everybody, whoever is there participating in this webinar. Let me, add my presentation, share my presentation. If you look at shrimp aquaculture, it's an evolving science. It is very, very dynamic, and it has been changing ever since the beginning of shrimp farming in India. It all started with P. monodon, which is our indigenous species, and we were struggling with WSSV and host of other diseases, which are vertically getting transmitted from the broodstock. So we have introduced Vaname as Dr. Prabhajit said in his inaugural talk in 2000, late 2008. And ever since the introduction of Vaname, we have been doing Vaname. But the industry kept changing because the dynamics are changing. And as you all know, this is a cold-blooded animal. The immune system is not well established in this animal. So you can't really come up with vaccines. And diseases keep emerging every year. I mean, in between introduction of anime and today, if you see, we have seen the emergence of AHP&D, which is otherwise called as EMS and EHP. So it is changing on a continuous basis, and industry also has to change to be in line with the changes. I mean, that's why we need technology. I mean, technological interventions are very much required in shrimp aquaculture more than other husbandry, because, as I told, this animal doesn't have established immune system. We cannot come up with vaccines, and the culture is done in the water, which you don't get to see. I mean, terrestrial animals means you get to see. I mean, aquatic animals you don't get to see, and fish, okay, you can come up with vaccines. For shrimp, you cannot come up with vaccines. So you need to address the problem through genetics, through husbandry changes, and basically it's all about technological interventions. That's exactly what I'm going to talk for the next 1 hour. Recent technological interventions in shrimp farming and hatchery management. Yeah, if you look at the production of shrimp aquaculture or shrimp farming in India, it has been on a rise ever since the introduction of vanillin. I mean, we used to produce about 1 lakh tons or so before the introduction of vanillin, and year 2019, 29 we have introduced 2009, and ever since then it kept growing. I mean, there was no drop of production throughout the last 12 years. And in the process, India has become the number one exporter in the world and arguably the number one producer as well. And 2019, we produced a record production of 8 lakh 4,000 tons. But this year, it is likely to go down. I mean, the reasons are plenty. I mean, COVID 19 is not the only reason. There are other reasons as well. I mean, as you all know, we have a huge outbreak of diseases in the second half of this year. So why is this drop? COVID-19 is not the entire reason for the likely drop. The disruptions due to the pandemic have impacted the production in the first half. Disruptions in the sense we were not able to bring the brood stock from March 22nd to June 16th or so. Almost for about 50, 60 days, we could not import the brood stock because the quarantine is closed because of the lockdown. And every broodstock that comes into the country, every batch of broodstock that comes into the country, it comes through the quarantine. I mean, there all the animals are checked for the known diseases. Then only it is released to the respective hatchery that's importing the broodstock. So that has been closed for 50 days during the lockdown, and they started their operations again somewhere in May 16th or so. So because of that, it got affected, and hatcheries could not sell their seeds initially because, I mean, the movement of vehicles has stopped. So hatcheries could not sell, so they had to grind the seed. And they, whatever good stock they were having, they could not give the feeds, also live feeds, because nobody is supplying the live feeds. Everything has come to a halt. So these disruptions have definitely played a role initially to drop the production, but subsequently quarantines operations have resumed on May 16th, and actually started importing good stock and all that. Good number of animals have come into the country since May 16th, but the production has not gone up. The second half, the apparent reason is the shrimp epidemics that we have. It's not about the pandemic COVID-19. It's about the epidemics what the shrimp industry is dealing with. I mean, we have diseases like EHP and other unknown diseases like white feces. The causative agent is known, the etiology is not known. It's also playing havoc, EHP along with white feces. And we have the good old enemy of this industry, white spot syndrome virus. It has been there for a long time. It continues to be there. It's also playing havoc. So we have battery of diseases bothering the farmers in the second half of the year. That has contributed immensely to the drop in production. Last year, if you look at, we have done much better in the second half than the first half. Historically, if you look at, we do well in the first half. Second half, we don't do all that well. But last year, we have done very well in the second half. Month on month, we have exported about 60,000 tons. That's one of the reasons why last year we have produced a record high of 8 lakh 4,000 tons. And we've exported to a tune of 640,000 tons or so. I mean, most of the shrimp what we export is headless. So about 33% goes off in the head. So our produced figure is about 8 lakh 4,000. And if you look at the exported figure, it's about 6 lakh 20,000 or 6 lakh 30,000. Because almost 95% of our shrimps goes as headless. So the export volume is always less than the volume what we produce. So apart from the crop losses, but because of the other diseases like EHP and white feces, the growth is very slow, and farmers are not able to take them to larger sizes. So, and the survivals are also badly affected. All these things put together is going to bring the production down for this year. I mean, another 1 month ago, but definitely it will not be more than 6,20,000 tons or so. I mean, it would be around 6,10,000. Even if it is less than 6 lakh tons, also we don't need to get surprised. And as I was talking about the good stock, let us have a look at the imports. This year, 2020, if you compare it with the 2019, I mean, January, we brought in more good stock. February, we brought in more good stock. March, we brought in more good stock. April, we could not import because RGCA quarantine was not functioning because of the lockdown. March 22nd, lockdown has been announced. Since then, I mean, we could not import anything in March, April. May 16th onwards, we started importing. So April, literally, there is no import. May, we could import good quantities from 16th onwards. So compared to last year, still we are down by about 46, 47%. And in June, we have imported more. In July, we have imported more. In August, we have imported more. In September, we have imported more. October, we have imported more. November also, we would be importing the same or more. The same is going to be the case in December also. So the point is, we have imported good quantities of good stock. So the hatcheries have produced good quantities of seed. Then why the production has not gone up? It's because of diseases. It's not because of any disruption that has been created by COVID. I mean, that's only for a couple of months, March and April. Even March and April also, if you look at, we've imported good stock, good quantities of good stock in January, February, March. That would have served in April, May also, even up till June, up till June. But these animals were not properly fed because there was no feed available. And hatchery operators were also going helter skelter because when lockdown was announced on 22nd, whatever seed they had, hatcheries, they could not sell it. Most of the hatcheries had to drain it. So they were not maintaining the good stock. And even if they wanted to maintain, the feed was not available. I mean, that has, put hatcheries in trouble, and they could not produce much of seed in May and June also. Whatever broodstock we started getting from May 16th. I mean, to start a cycle, it will take some time. I mean, you can't work on the broodstock right away. I mean, at least you need to acclimatize them for about 10 days, then you need to do the ablation and all that, and first 20 days you don't get of much of nuclei. Nuclei is the first stage of the life cycle of shrimp. So I mean, after importing broodstock, it takes about 20-25 days to get the nuclei, and to convert the nuclei up to PL, it takes about 20 days. So after the import of broodstock, after 50 days only, you would be in a position to supply seed. So May 16th onwards, hatcheries have started importing, means July onwards only, they started having seed from the fresh broodstock. Till then, whatever they have is from the old broodstock, and the broodstock was not properly fed in between because of the lockdown. So that has created some trouble in the farming as well. But subsequently, whatever they were stocking from July onwards, they had plenty of seed, and most of the hatcheries were producing and supplying. I mean, that's about the broodstock. I mean, this is the graph which gives you a comparison between the broodstock imports of 2018, 2019, and 2020. It's no less. Only it's less during the months of April and May. Any other month, if you see, it's higher than 2018 and 2019. So definitely, broodstock import or not having good stock is not the reason at all for the drop in production. Maybe it contributed to an extent, in not having good seed in the months of June, July, first half of July. But afterwards, we had enough seed. But the reasons, as we have discussed, or something else. Yeah, that is the challenge of diseases. I mean, diseases are definitely the reason for the drop. I mean, the good old foe of WSSV continues to trouble the industry. It's been heckling the industry right from the word go, and this year also. I mean, it's affecting the shrimp farming in Andhra Pradesh to a great extent. If you look at Andhra Pradesh, that is the state that produces close to 65 to 70% of the shrimps in the country. And during the second half of the country, not many states they go for farming. Whereas Andhra, the farming is there right from the beginning of the year to the end of the year. So second half, usually Andhra does in a full-fledged manner. But this year, WSSV is really heckling the farmers and making farmers lose the crops. And emergence of EHP and white feces is one obvious reason for drop in production. I mean, white feces, the etiology is not known. As I told you earlier, EHP has become endemic in India. I mean, this is a new disease that has come about in 2013, 2014, and now it's in full swing. It is going full throttle, and it's almost kind of become endemic. It is there everywhere. In each and every state, it is there. In each and every water body, it is there. So it is not giving any respite to the farmers. I mean, these are the reasons why farmers are not successful this year. The survivals are coming down with increasing days of the culture. I mean, so many of the farmers are forced to harvest at smaller sizes. Usually, Indian farmers they target for 30 counts. That's about 33 grams. But these days, farmers are not able to take their culture to that level. Somewhere in between, they're forced to harvest at 60 counts, 70 counts. Even if some of them are trying to take it long to get the sizes, they're not able to do it because the growth is not there. The survivals are not there. It took some time for the farmers to understand this. And now many of the farmers, they understand this. So they're not trying to pull the crop too long. I mean, they're harvesting somewhere in between at 60, 70 counts. So to get the root of the problem, we at Society of Aquaculture Professional, when I was the president, we have done an epidemiological study along with University of Arizona to understand what is causing this white feces. And we have come up with few inferences. I'll discuss about the whole study. We have taken about 155 samples with classic symptoms of white feces. Out of that, 12 samples have come negative for the EHP. So what we've come to understand from that is EHP is not the causative agent. Maybe it's exacerbating the problem, but it is not the causative agent because 12 samples out of 155 samples with classic symptoms of white feces, they found to be negative. Then we thought probably there could be some other, pathogen that is causing white feces. So we have tested for all the OIE listed diseases like CMNV, IMNV, EMS, and none of them are present in the samples, in all the 155 samples. But for EHP, that also it is there in about 133 samples. Other 12 samples, it's not there. 143 to be precise. In 143 samples, we have found EHP. And one interesting thing what we have found is in the salinities where the culture is done at 4 ppt and 5 ppt, the impact doesn't look to be threatening. Despite the EHP, the animals are growing. And in the samples that have come negative for EHP, the growth looks to be good. Though white feces is there, the animals are going good. Look at these data. I mean, most of these samples are at low salinity, and if you look at the ct value of EHP, I mean it is very very low. I mean the ct value of a disease is low means the virulence is high. In the case of EHP, the spore count is very very high. EHP is basically a microsporidian, a fungi, I mean with the spores, fungal spores. I mean, when the spore count is very, very high, the CT value is very low. Even in COVID, I mean, now they're trying to look at the virulence. Trying to look at the CT value. If a patient is having low CT value, means the virulence is very, very high. I mean, the patient has to be immediately admitted in the hospital. If the CT value is high, the virulence is low. I mean, now COVID abroad, they're treating that way. I mean, in India, so far, they're not giving the CT values in the RT-PCR. Some of the hospitals could be giving, but US and all that, now they're looking at the CT value. If the CT value is low, immediately the patient is admitted in the hospital. Similarly, if you look at the CT values, I mean, see, we have taken a sample from West Bengal where the salinity is 7 and the stocking density is very high, 60. I mean, in Indian conditions, 60 per square meter is supposed to be high because most of the farmers, they go for 30, 35 per square meter these days. So in Bengal, one farmer at 60 salinity, at 60 per square meter density and 7 salinity, I mean, despite EHP is getting good growth, 77 days, 18 grams. And the CT value is very, very low. Means the virulence of EHP or the spore count is very, very high. So surprisingly, EHP doesn't look to be having a big impact in the areas where the culture is done in low saline waters. That is one of the reasons why the culture in East Godavari, West Godavari, and Krishna district is still thriving, whereas at other places the results are not all that good. In these three districts, culture is done with subsurface water, bore water. I mean, because of Godavari, we have copious groundwater in East Godavari, West Godavari, and Krishna, and they're doing very well despite all these diseases. Whereas you go southwards in Andhra Pradesh, in Ongole and Nellore, the culture is not good. Same is the case in Tamil Nadu. And one of the states which used to be very, very successful in the country, Gujarat, is not doing good because most of the culture is done in brackish water, the water that comes from the creek. I mean, they don't do culture with bore culture. Probably Punjab could also do well because you use bore water, though it is having a salinity sometimes 10, 8, and all that. I mean, basically the water is from the bore, so you might not see the impact of EHP in Punjab also. And if you look at the ponds where the culture is done in higher salinities, the growth is definitely slow. I mean, the stocking densities, if you look at, the stocking densities are low, and CT value is not as low as it was in one sample from West Bengal, means the spore counts are not very, very high. The stocking densities are less, so there is no much of stress because of the stocking density, and but the salinities are high, so the animals were not growing. So salinity is definitely playing a big role when it comes to EHP. And data from the negative samples, I mean 12 samples which have come negative for EHP. If you look at the growth, I mean it is not bad. So what we understand is, I mean, this is not just EHP alone that is contributing to white feces. Probably it's exacerbating the problem. So what we asked the University of Arizona to do is, okay, we have done molecular test here. We could not do the histology. So we requested University of Arizona to do the histology. So we have sent all the samples for histology. They could not find any enteric bacteria. I mean, they've tested for known diseases and they try to figure out whether there is any other enteric bacteria or any other enteric pathogen, and they could not find any enteric pathogen. So what we get to understand is probably Vibrio is playing a role. I mean, if you look at different water bodies in the country, the microbiota has changed. I mean, the microbial composition in the water bodies have changed, in the brackish water especially. Probably, a particular strain of Vibrio could be contributing to the white feces. And if it is coming along with EHP, it's playing havoc. I mean, that's kind of a conclusion we could come up with. You could say it's a conjecture, not even conclusion, unless and until we prove it, on a scientific basis, we cannot say that. But all over the world, what the experts are saying is definitely some kind of vibrio in tandem with EHP is creating this problem. So sometimes if you have a white feces and if EHP is not there, the animals are still growing, though you have white feces. So a combination of vibrio and EHP could be the reason is what we're thinking. So we need to somehow address both the problems. How you get rid of the EHP from the hatchery viewpoint and from the farm viewpoint, what all kind of measures you need to take to see to that there is no EHP. At the same time, how do you suppress the bacterial load? If you can suppress the bacterial load, probably EHP on its own will not harm the shrimp much. I mean, that's what we understood by seeing the samples that we have collected from the ponds where the salinities are low. The salinities are low means the water is coming from the ground. I mean, groundwater is devoid of bacteria. It will not have any bacterial loads. I mean, all the bacteria comes from the creek water. It's not coming from the bore water. I mean, we could come up with that kind of inference also from this data. Probably, it's the bacteria that is coming from the brackish water in tandem with EHP is creating all the trouble. We will have further discussion on the causative reasons and how we can suppress and all that. The possible causes, the problem looks to be the same in most of the Asian countries. It's not just happening in India, it is happening across the shrimp farming countries. I mean, be it China or all other Southeast Asian countries or India, the problem is the same. I mean, the white feces and EHP. And what is the common thing? I mean, broodstock source is the common denominator in all these countries. We're all getting from the same breeding companies from the US. I mean, whether inbreeding has set in, because if you look at the founder population of all these breeding programs, it's very, very narrow. Probably because of that, the animals have lost immunity. I mean, the microbiota could be the same, but you know, probably the animals have become less immune. I mean, everybody is kind of, having these kind of doubts. Prabhajit ji?
Sorry, it got stopped by mistake. I'm sorry
No,
for
no,
it.
no problem, no problem. Shall I add it or you can?
You have to edit.
Yeah. So, um, are you able to listen to me?
Yes, yes,
Oh, okay, okay.
very much audible.
Okay, okay. The problems look to be the same as I told you, and rootstock source is one common denominator in all these countries, And as I told you, because of the inbreeding, they must have become, or apparently they might have become less immune against the bacteria, because the problem looks to be the same in all the countries, and the broodstock what we use is the same. This is one apprehension so many experts have come up with, but there is no clear-cut answer for this. Probably it could be one of the reasons, or is the global warming the reason? Everywhere the temperatures are going up. Because of that, the microbial constitution has changed. We don't know. Or all these problems we started seeing after the emergence of a disease called AHPND. Probably the bacteria has come along with the broodstock into the other countries as well, and afterwards it has changed its characteristic. We don't know. I mean, initially when AHPND has hit Thailand, there was early mortality syndrome. That's why it's called as early mortality syndrome. Whereas we are not seeing any early mortality, but subsequently we started losing the stocks. I mean, after 40 days of culture, and white feces problem and all that. So I mean, one of these things might have happened. It could be because of a broodstock losing immunity. It could be one reason, or it could be because of the global warming. The microbial constitution might have changed, or uh, the AHPND, which has hit Thailand in 2012 through broodstock, that particular strain of bacteria with the parahelminthecus might have come into the other countries, and you know might have colonized in all the water bodies and all that. So, but the characteristic of the vibrio might have changed, and it is contributing the losses in a different manner.
Sir, can you share the screen, please?
Uh,
We are not able.
You're not able to see me, right?
You have to share the screen, please.
Yeah, let me see.
Otherwise, we can do it for you.
Okay, please.
Jitendra, I am forwarding your presentation. I am unable to open it here.
Please
Please,
send me, sir. I'll just do it.
I have done it. Please share it. Sorry for the trouble. Actually,
It's
I
all
was
right, no
trying to
problem.
pin your video, and it somehow it
No, no,
happened.
all over the world, now the trend looks to be changing. Some of the breeding companies have come up with tolerant stocks. There is definitely a paradigm shift. Earlier, they used to talk about fast growing lines. Today, they're talking about tolerant lines, the lines that are robust, resistant, and tolerant for pathogens, especially the bacterial pathogens. Some of the companies already started supplying such stocks to India, and the results are very, very promising. And every breeding company worth its salt in the world is working on the tolerant stocks. So if you go by this, I mean, it supports our argument that the earlier stocks were becoming less immune towards pathogens. So probably because of inbreeding reasons. So now everybody is coming up with tolerant lines. That looks to be the trend today. And whoever have come up with tolerant lines, those tolerant lines are doing very good. It could help both the hatcheries and farms. And in India also we require the tolerant stocks. And we have started importing, and few other hatcheries have started importing. The results look to be very, very good. And this could be one of the solutions for the problems what we have today. And it could help the farmers in combating the white feces also, white feces and the running mortalities, because it looks to be a bacterial issue. So if you have tolerant stocks, you could overcome. And in future, if breeding companies can come up with EHP tolerant stocks, I mean, it would be a game changer. See, the solutions for any problem in husbandry, be it shrimp or other husbandry, I mean, always we could get solutions from genetics. But they need to find out if they're able to get some resistance for EHP. They need to see whether the resistance is heritable or not, whether they can pass it on from one generation to next generation. First of all, they have to come up with some stock or some lines which are resistant for EHP. After finding out, I mean, they need to see whether this resistance, this trait of EHP resistant is heritable or not. I mean, can it be passed on to the next generation or not? If you look at white spot, one of the reasons why breeding companies were not able to come up with WSSP tolerant stocks is it is not heritable. The resistance doesn't look to be heritable. That's why though we had this problem for a long time, we are not able to come up with resistant lines. Probably breeding companies are going to work on EHP tolerance. Once we have tolerant stocks for EHP also, I mean, we could overcome the set of diseases what we have today. Then there will be emergence of a new disease. It's always like that, you know, always there is a race between, genetics and the diseases, you know. The genetic companies will come up with some kind of a solution through genetics, and then a new disease comes. That has been the case right from the beginning, you know. So again, we're talking about WSSV. How do we address the problem? I mean, farmers, they're well versed with the problem. Once they see the WSSV, they know it's WSSV. They know what is the kind of biosecurity measures what we need to take, like crab fencing, bird netting. How do you stop the vectors coming into your farm? You know, I mean, disease comes through, the other vectors like birds. Birds could be carrying the shrimp and drop it. Otherwise, they could eat the shrimp and they could, drop the feces while flying over a pond. And the pond in which the bird is dropping its feces, the pond could get contaminated and infected with white spot. That's why we try to come up with bird line all over the pond to scare the birds fly over the pond. And you have crab fences all over the pond individually and for the farm as well. So the crabs cannot come into the farm. Crabs are carriers of disease. Crab is a crustacean, they're carriers of disease, they're carriers of white spot. And you screen the water to get rid of all the small crustaceans which could be the vectors of WSSV. All these precautions are taken. Biosecurity measures are well established for avoiding white spot syndrome virus. So most of the farmers, they do practice all this, but still WSSV comes once in a while, you know. So farmers are alert and vigilant. Survival. If farmers are alert and vigilant, survivals are not affected. If farmer comes to know that he has a white spot, immediately he orders for ice and the vehicle, you know, because he knows it doesn't give him much of time. It has been there for long now. Farmers are very aware of the disease. You know, once they see it, they immediately call for ice and the, a van, insulated van. So they'll harvest immediately. So they're used to the disease, and most of the farmers are alert. So that way they're able to, overcome WSS. Even if it is there, they're not losing money. You know, they don't wait. But if somebody is losing before 7 grams and all that, they lose money. If the animals are above 7 grams, if they're hit with a white spot, they don't tend to lose money. Whereas that's not the case with white spot, with EHP and white feces. You know, I mean, you keep losing the stock, the animals don't grow, and you keep fighting. And usually, you don't get to understand the symptoms also all that well. I mean, stunted growth is one major symptom for EHP, but because of some other thing, also sometimes your animals don't grow. So you're not really sure that you have a problem of EHP if there is no growth. That's why diagnostics play a big role. If you have a problem, if your animals are not growing, you should take your shims to a diagnostic lab and get them tested, which in many cases they don't do. You know, I mean, the animals are not growing because of some other reason they think, and they tend to increase the feeding also. I mean, the animals don't take the extra feed what you're giving, but you're spoiling the bottom as well. So I mean, it is adding insult to the injury. You're already having EHP problem, and you're adding more feed, which is spoiling the bottom, thereby increasing your bacterial load. So your bacteria is increasing on one side, and already you have EHP. It is like a recipe for failure, you know. So you keep doing it, and you keep losing the stock, and whatever animals you're left with also, they're not growing. You know, thereby the farmer is losing money. So, what are the other measures that can be taken to address the WSSV? Area specific crop holiday could help the farmers because you have a white spot syndrome virus, say, in your farm. The neighboring farmer doesn't have, but he thinks, okay, next crop I can do well and all that. It could get affected because your neighbor had a disease outbreak. I mean, the animals around that farm, the crustaceans around that farm, crabs and other crustaceans, they might have been infected, and you had a good crop, thinking that my neighbor had a problem, or my next to my neighbor had a problem. I'm not going to face any problem. I mean, that's wrong. I mean, those crustaceans could come into your system and infect your animals. So area-specific crop holidays are very much required. If there is an outbreak, the whole area should go for a crop holiday and see to that most of the crustaceans in that pocket are dead and are taken care of. So area-specific crop holidays are definitely a solution for WSSV, and many farmers they're doing that also on many creeks in Andhra Pradesh and Tamil Nadu, and even in Gujarat they do that, and it is definitely offering a good solution. So the collective spirits and understanding among the farmers, is one thing that could help the farmers to check this contagion. And nurseries could also benefit the farmers because it gives them time to prepare the pond, because every farmer is to an extent greedy, because they look at the global prices and they want to go for the next crop. But if your preceding crop was a failure, you tend to have some traces of the disease in the crustaceans around your farm. So if you're preparing your farm in a hurry, I mean, then you're going to get again infected. If you look at some big farms, white spot disease is recurring. I mean, it doesn't leave them because they've never given good respite. They've never tried to completely do away with the disease. They were always preparing in a hurry and trying to go for the next crop again. You know, so if you have a nursery, that also gives you enough time for you to prepare. So you can completely get rid of the traces of white spot in all the crustaceans that are there. And we have discussed enough of EHP and white feces and running mortality. Now we'll try to discuss what we can do. White feces problem, as I've been telling you right throughout, it looks to be very, very threatening. That is one of the changing dynamic of shrimp aquaculture. What are the how we need to change the husbandry. I mean, we'll discuss about that. Running mortality syndrome looks to be more pronounced in summer. Probably, again, it could be bacterial. In summertime, the temperatures are high. The proliferation of bacteria is very, very high. So probably the bacterial strain that is contributing to the running mortality, it is growing big in number in summer times, whereas you don't get to see these running mortalities in the months when the temperature is below 25, 26, the water temperature. As of now, I mean, both the problems are idiopathic, means the causative agent are not known for sure. This is a kind of a speculation and a conjecture we're coming up with. This could be because of this, but it has not been scientifically established as of now. EHP is a parasite with complex life cycle. The spores are very, very small in size, and they don't get killed. I mean, sometimes they stay for years together in the soil. So, and they're also playing havoc, as we have discussed, they're contributing to the stunted growth, and thereby, contributing to huge losses to the farmers, because the animals don't grow. Whatever feed you give, it is consumed by the spores. The energy is consumed by the spores in the hepatopancreas, whereas the animal doesn't grow. The spores are growing, contributing to further losses. So this is definitely a serious problem. EHP is possibly not associated with white faces. We discussed about this also, because 12 samples out of the 155 samples with classic symptoms of white feces have come negative for EHP. So EHP is possibly not associated with white feces. But along with white feces, definitely it is playing havoc with the farmers. That we understood, from the data also. So measures to be taken to control EHP in farming. I mean, from where it is coming? I mean, it must be coming from the seed. So seed has to be tested when you're buying it from the hatchery. When the farmer is buying it from the hatchery, seed has to be tested. Suppose if they're going for a nursery two-stage culture, I mean, the juveniles that are coming out of the nursery have to be tested. This is a much foolproof way of testing, because sometimes EHP might not be captured when the seed is tested, but when the juveniles are tested, definitely it can be captured. So if you have a nursery and testing the juveniles that are coming out of the nursery. I mean, the 1.5 gram animals or 2 gram animals which are coming out of the nursery, if they are tested for EHP, it's a much more foolproof way of checking the stock that you're taking into your farm. It acts like a quarantine as well. Okay, you bought a batch of seed, you got it tested for EHP, but again, after growing them in the nursery for about a month or so, again you are getting them tested. So your nursery would act like a nursery as well. So if you're getting it positive, it's better to sack that stock. I mean, okay, you spend some money and all that, but if you go and stock these juveniles with EHP, you could further lose money. So nurseries could be used like quarantine before stocking. And you have to test the soil also for EHP spores, because it might have come from your preceding crop. You don't know, and these are tiny tiny spores. I mean, they get mixed up with soil. It is difficult to test the soil and understand also. But what you can do is, I mean, at the central pit in the middle of the pond, where you have this organic load, this sludge and all that, collect the soil from the kind of an area and test it, because the spores also tend to come towards the sludge pit. So collect the soil there and give it for testing. So if at all, if you have EHP spores, you'll come to understand, then you'll go for better preparation. And a way of preparing the soil to avoid EHP is alkaline treatment. I mean, one of the most often used alkaline treatments is quick lime or burnt lime. We give it 6 tons per hectare. It's alkaline treatment. The pH is very high. When the pH is high, the spores get killed. You need to take the pH to a level of 12, 13. So with 6 tons of calcium oxide, you can take the pH to a level of 12, so that you can inactivate all the spores. So you have to give this treatment when the soil is wet, when the soil is moist. If the soil is not moist, if it is well dried and all that, you moisten the soil, you add water, then apply calcium oxide. Then only, I mean, the pH goes to that high, and you get to see the desired results. There are other kind of alkaline treatments. Some people, they give 2.5% sodium hydroxide. They wash the surface. Usually, this is good for firm surfaces. I mean, you have a line pond and all that. Wash the liner with 2.5% aqueous solution of sodium hydroxide for 3 hours. I mean, the contact time should be minimum of 3 hours. Then the spores are going to get inactivated. Then you use acidified chlorine of 200 ppm. The pH is going very, very high. So again, you need to bring it to the neutral level. So if you use acidified chlorine, you can disinfect as well. You can bring the pH back to 7.5, the normal level. Uh, Suppose during the course of the crop, if you are finding EHP, water exchange could help, because water exchange could reduce your bacterial loads. So we all know it's not just because of EHP. If it is just because of EHP, it should not give good growth rates in the ponds where the culture is done with bore water. So to address the problem of bacterial loads, you do water exchange so that you can reduce the bacterial count. Then the effect might not be as detrimental as it is in high salinity, as it is otherwise. And you can do also the partial harvest. If you're doing the partial harvest, I mean, if you're removing some animal, definitely you can reduce the bacterial count, because the organic load is going to get reduced. There is not going to be any feed wastage. The excreta, what goes to the bottom from all the shrimp, that is going to go down. So overall, your organic loads are going to come down in the pond, and thereby the bacterial loads. So whenever if you see EHP, I mean, if you are going for some partial harvest and water exchange farmers are able to take the other animals further and come up with a reasonable crop. But again, you need to look at the CT value. If the CT value is very, very low in your RT-PCR, it is better to harvest. It is better not to fight. But if your PCR value is high, probably then your water exchange and partial harvest could help. And the other thing that could help is the functional feed. I mean, functional feeds are definitely helping in farmers reducing the bacterial loads. Probably because of better formulation, the wastage looks to be less with the functional feed, and it might not be contributing to too much of organic load. That's why whenever farmers are facing these problems, when they're using functional feed and do some partial harvest, the crop is able to proceed further. But again, as I told you earlier, you need to look at the CT value. Not many farmers are looking at the CT value, but many people, many progressive farmers have understood. I mean, whenever we have a problem, we need to check for the EHP. At the same time, we need to see the CT value. If the CT value is low, means the spore count is high, it is better not to further progress the crop. It is better to harvest and salvage whatever you have on hand. Changes needed to suppress bacterial load. The thrust should be on suppressing the bacterial load. We have discussed a lot about that during the course of my talk. Clean seed, I mean seed that is free of EHP, free of bacteria. Clean water, clean pond bottom would help the farmers in reducing the bacterial loads. You know, if your bottom is not clean, definitely it would contribute to a lot of organic load, which in turn would contribute to your bacterial loads. So you need to have clean bottom. So your pond feed management got to be perfect, and you need to use a good feed with very good formulation, and you should have controlled feeding. You should not dump feed into your pond, excess feed, because excess feed will go to the pond bottom and contribute to the organic load. So control on the feeding is very, very important, and drawing the clean water. If you have a bore water, of course it's clean, it's devoid of everything, and checking the seed at the hatchery is very, very important. If you're having a nursery, definitely you can check the juveniles. So all these things could help the farmer. I mean, having a control on the seed, taking the of seed that is free of diseases, having clean water, having clean pond bottom, all these things would help. And different countries are approaching the problems different way. If you look at China, China is going for all tolerant stocks. I mean, they're coming with the solution through genetics. I mean, earlier leaders, the breeding companies, whichever were leaders like 4 5 years back, I mean, who were usually supplying regular fast growing SPF lines, they're no more in business in China. I mean, the leading suppliers in China right now are the companies which are giving tolerant stocks. That's how China is coming up with a solution. Whereas surprisingly, Vietnam has gone for a different kind of a solution. They're asking for growth lines. They're saying, you give even lines which can grow even faster. You know, what they have done is they have gone for system diversification. What they have done is they're going for multi-stage culture. See, it's not just about a nursery and a grower. What they're doing is a nursery wherein they hold the animals for about 25 30 days. Then they have pre-growth facilities. They take it to the second stage from the nursery. They grow the animals till they reach about 4 5 grams, about 30 35 days, and another pre-growth stage. Second, that is second stage they're taking, or third stage. If you take it nursery as first stage, then second stage, third stage. They're keeping them for another 40 days and another 40 days in the last growth. Basically, they're trying to do it in 4 stages, and every stage they see to that it is not crossing 40 days. They understood the problems are because of bacteria. If you take that particular stage beyond 40 days, there is a chance for buildup of organic load, thereby the buildup of bacterial load. So they're trying to break that bacterial buildup chain, you know. So they're restricting each stage to about 40 days or less than 40 days, and four stages. Some of them are doing three stages. So they're getting good survivals, they're getting good growth. That's how they're addressing. So whereas India, we are neither there nor here kind of a situation. We are going for two stage. Most of the farmers are going for two stage culture, nursery and grow out. That is also helping us. And we are trying to switch over to tolerant lines. I mean, to an extent, that's also giving a solution. But changing the infrastructure entirely to make it four stage, it could be difficult. Probably we can go for a three stage culture, like the way you do in fish. It's exactly like the way you do fish. Fish is also sometimes done in three, four stages. Dr. Prabhajit knows better than me about fish. So, in shrimp also, we need to go for those kind of system diversifications, especially in the places where they depend on the creek water. You know, they cannot get the bore water. They cannot have water that is devoid of, bacterial loads. So, it's better to go for four stages, at least three stages. With minimum modifications, you have to come up with this kind of a system to overcome the problems what we are facing today. This kind of intervention is very, very required. Probably in years to come, we are going to go for this kind of system diversification. Already, some of the progressive farmers in Andhra Pradesh, they're doing this kind of a diversification, system diversification. What they're doing is they have a nursery, and somewhere in the middle of their farm, they're converting the existing ponds into smaller ponds with line ponds, and they're bringing the juveniles from the nursery ponds and stocking in the ponds which they've created in the middle of the farm, which are lined. There, the densities are high. Initial densities in the nurseries are about 2000 per square meter or 2 per liter. And when they shift to the next stage, they stock about 200 per square meter. And the size of the pond should be small, 0.25 hectares or zero point 0.1 hectares, square in size, so that easily you can remove the sludge. So stock at 200 per square meter there, and there you do the culture for another 30-35 days. If you're keeping these ponds in the middle of the farm, it's easy to shift bigger animals like 7 grammers and 8 grammers into the adjoining ponds. Some of the farmers have started doing this, and I think in future many farmers from other states like Gujarat, West Bengal, Odisha, Tamil Nadu, and the belts in Andhra Pradesh, which depend on creek water or brackish water, they have to go for this. The farmers who are doing the culture with bore water or subsurface water, they can continue the usual way. Even if they don't go for this kind of multi-stage culture, they're okay. And stocking tilapia in reservoirs and inside the cage within the pond also could help, because if you look at tilapia, the bacteria that is there in tilapia farm is mostly gram positive, whereas the bacterial loads what you get to see in shrimp or gram negative bacteria. So if you add tilapia into a pond in a cage and all that, you could inhibit the growth of gram negative bacteria, which is apparently contributing to the problems what we get to see today. So if you're not adding tilapia into the pond, you can definitely add the reservoir. You can do it sequentially. You can do a tilapia in the reservoir, good number of animals, few thousand you can keep in the reservoir, and take the water from reservoir into your pond. So the water that is coming in, it is having a lot of gram positive bacteria, and it would definitely inhibit the growth of gram negative bacteria in your shrimp pond. It would definitely help. And if you can introduce some of the tilapia directly into the culture pond, also it helps, because it eats all the moribund and dead animals of shrimp. You know how the transmission happens within the shrimp pond. It is through cannibalism. So these tilapia could break the chain. They will go and eat the dead animals and the moribund animals. so they could stop the chain of the transmission, so uh, in the places where the problems are plenty, probably tilapia could be introduced within the culture ponds also. Otherwise you can have them in the reservoir and take water from the reservoir into the pond to control your bacterial loads. Reduction of densities and shortening the crop is definitely a solution. The longer the crop, the longer the bacterial load. So shorten the crop. You can shorten the crop by reducing the densities. So you could minimize your losses and try to be keep your operations, profitable. And the other doubt what we had right at the beginning of our discussion, what I was talking about is the microbiota might have changed. I mean, we need to do microbiome studies also using metagenomics. I mean, what is the kind of microbiota what we have in the water source in the creek? What is the kind of microbiota we have in the soil in the pond? And what is the microbiota that is there in the gut? We need to study. Then only we can come up with solutions. Today, whatever probiotics we are using, whether they're coming in handy or not, also we don't know. I mean, most of the probiotics what we have today, they've been there for the last 20 years with the same kind of strain. They've not changed, but the water is changing, the water body is changing, the microbial constitution in our water bodies is changing, but we are not changing the probiotics, the beneficial bacteria what we use in the shrimp farming. So there is a lot of work to be done. Probably universities like ours, can take up the job, the microbiome studies. That's one very interesting area, I would say. And these are the pictures of few nursery line ponds. Nurseries are done differently. I mean, these are point 0.1 hectare line ponds wherein we stock PL20 and we keep them for 25-30 days. And if you're stocking at a density of say 3 per liter, they might go to a level of zero point 0.5, zero point 0.6 grams. Then you shift them into your grower ponds. I mean, if you have just a two stage, if you have three stage, you can shift them to pre-grow, keep them for 1 month and then shift. And we have other kind of this is also a lined grower pond, and you have these kind of ponds, which are above the ground, and in this just talk about 3 per liter or so, and harvest 1 grammers, 1.5 grammers after 35-40 days. And you have cement tanks. Some of the people are even using cement tanks like what you get to see in the hatcheries for nursery. So you have different kind of nurseries, outdoor, indoor, semi-outdoor, semi-indoor, and line ponds. Whatever it is, the basic idea is hold them for some time so that you could reduce the length of your crop. That is the premise, and you can take it to the next level, like the way in Vietnam they're doing. You can go for 3 stage or 4 stage as well. And clean water. We have been talking about clean water. Okay, what we have discussed earlier is if you're taking water from a bore, subsurface water, it is clean. If it is saline water like 5, 6, or 10, whatever, it is free of any bacterial load. But when you're taking it from the creek, how do you treat it? Earlier, we were only treating it with chlorine. That's not enough today. You need to improve the definitely the carrying capacity. I mean, the carrying capacity is getting limited because of the organic load and the bacterial load that is there in the creek. So today, people are using more tanks for sedimentation. They're giving some of their culture tanks, they're leaving some of their culture tanks for sedimentation. They're allowing the water to settle and have clean water. So along with the physical turbidity, the bacteria will also go. And after sedimentation, they're using polyaluminum chloride to get rid of the organic uh, carbon that is there in the water, the physical turbidity at about 10 to 15 ppm. It makes the water much clearer. To get rid of the physical turbidity, polyaluminum is chloride, especially all the farms that are, on the side of a creek, they're taking the brackish water from the creek. This is definitely helping, and it gets rid of the physical turbidity. Along with that, some of the EHP spores also one can get rid of. And if a creek is infested with EHP, potassium permanganate treatment of 5 ppm to 15 ppm can be given. after treating the water with polyaluminum chloride. That's also helping. I mean, potassium permanganate, it's a good disinfectant and it is killing the spores also. It is deactivating the EHP spores. So, I mean, if somebody is located on a creek and in the middle of a farming area, definitely you're going to have all kind of diseases in the water what you're drawing in, the EHP, the strain of bacteria which is contributing to white feces. So these kind of treatments could help. And if somebody treats the water this way and go for at least a kind of a three-stage culture, probably he could suppress the bacterial loads and try to do away with the problems that are contributed to the farming by EHP as well. So this is the kind of intervention that is required. I mean, you need to change your water treatment procedures and you need to go for multi-stage treatments that could overcome the problems what we are facing today. And the other thing is, whatever feed today, that also could be contributing to the problems what we have, because most of the formulation is compromised. I mean, feed mills are not able to increase the price, but if you look at the ingredient prices, they're increasing by the year. But feed companies are not able to increase the price because there is a whole lot of competition. Today, we have more supply than the demand. I mean, if you look at the installed capacity of all the shrimp feed mills in India put together, it's about 2.5 million, but the requirement of feed is only about 1.2 million. So these guys are not able to take the price up. And whenever we use the functional feed, when you have a problem, we are able to, get some respite. What it indicates is one of the major differences between a functional feed and a regulation feed is functional feed has more of protein, that too marine protein, not the vegetable protein, not just the soya. So whenever you give this feed, the animals they feed on it. There is no much of wastage, and it is getting converted into biomass. It is getting assimilated. It is not going as a waste in the excreta. So the problem seems to be getting subsided. So feed also could be one of the reasons for the problem. But if a feed company is coming up with a feed which is higher in price, farmers might not buy. What farmers need to look at is not the cost of the feed. They need to look at the costing. If they use a cheap feed, which is contributing to all these problems, your FCR is going to shoot up 1 is to 2 or 1 is to 2.5. Then your cost is going up. I mean, cost of feed in your variable cost of feed in your costing goes up. But farmers are not looking at, they're just looking at the cost of the feed. So, feed mills are not able to come up with change in formulation, and farmers are not interested if somebody comes up with an expensive feed also. But I mean, some of the farmers were looking at things very closely. They're mixing with functional feed. They use one feed, functional feed every day in the morning. Other three feeds they go for regulation feeds, and whenever they have problem, they switch over to functional feed for 4 5 days, and once the problem subsides, they go for the normal feed. So switching over to auto feeders could help the farmers because there is so much of feed wastage in the manual feeding. If you go for auto feeders, definitely you can save some feed and you can save the pond bottom also from the organic matter. I mean, it is a definite solution to the problems what we have auto feeders. I mean, today you don't get the labor also easily. So if you switch over to auto feeders, you could, save money on the feed. At the same time, you can have a better crop because you can manage your pond bottom in a much better manner with auto feeder than the manual feeding. Organic matter, definitely it is contributing to the host of the problems in the ponds. We have discussed about it enough. I mean, to get rid of the organic matter, most of the farmers are coming with the sludge pits in the center. The whole sludge comes to the center because of your aeration. I mean, you have aeration, you need to come up with your aerators in such a manner that everything comes to the center. So you take the sludge on a continuous basis by having a pump there, submergible pump there. Some people take it out through gravity, but most of the people are taking it through the sludge pump. So you're able to manage the sludge, but where are you throwing your sludge? You're throwing it back into the source, and farmers are drawing it back. You know, okay, they take the water at the time of high tide, but still there is so much of sludge. I mean, you are making the your source of water full of sludge, so that's also contributing to the problem. So you need to have a proper disposal of your sludge. You cannot throw your sludge back. And earlier and all that, we used to do tiger. We used to go for very low densities. I mean, no farmer was going for this kind of high density, and this much of farming was also not there. Today, you have explosion of shrimp farming on every creek. That's one of the reasons why we have moved from 1 lakh tons of production to 8 lakh tons of production. So all this is going back into the creek, creating more problems. So sludge removal is good, but it has to be disposed in a proper manner. It cannot be thrown back into the source. Farmers should plan sludge pit depending on the shape and size of the farm, and come up with some design and dump it in the farm itself in the pit, and dispose it in whichever way that's possible. The other thing is lower densities. We have discussed about that. Obviously, less risky even on the creeks with too many farmers, because you are not creating too much of organic load in your pond. As you have lower densities, the feed wastage is going to be lower, relatively lower, as your densities are low, and the excreta that is coming from the shrimps is also going to be low, and you can manage your pond water much better, thereby the bacterial load. So lower densities could be one solution, especially in the places where you have explosion of shrimp farming. Ah, the other point, change of protocols in the hatcheries. So most of the diseases are coming from the seed. It is getting vertically transmitted from the broodstock to the seed, and from the seed to the farmer. So earlier, when we were doing tiger, we used to thoroughly rinse the eggs and nuclei. The eggs, when the animals spawn, first the eggs come out. We used to wash them thoroughly, and we used to wash the nuclei also, the first stage of life cycle of shrimp, which is called as nuclei. It is there in that stage for 36 hours. We used to thoroughly wash the nuclei also, to get rid of all the pathogens. They're all attached, to the eggs and nuclei. So we used to wash them thoroughly, so that whatever nuclei that is going into the larval section is free of pathogens. But after starting SPF Vaname, we stopped doing it because it's SPF. We started going for mass spawning, and we were not washing the eggs and nuclei. We were directly taking it to the larval breeding sections. But today, we are challenged with different set of diseases. I mean, the bacterial and fungal. So again, we have to start practicing this egg washing and nuclei, which most of the hatcheries have started doing already, especially the leading hatcheries and the progressive hatcheries. They all started doing the egg washing and nuclei washing. And like the way we have discussed, we need to go for alkaline treatment. Earlier, we used to disinfect the maturation tanks and the other paraphernalia in the hatchery just with chlorine and formalin. But today, we need to go for some kind of alkaline treatment. I mean, sodium hydroxide treatment is the best for the firm surface. I mean, we can go for 2.5% aqueous solution, wash off all the tanks and the entire paraphernalia, the PVC pipes, the buckets, what you use, and all that, and dry them for at least 1 week after rinsing it with acidified chlorine or 200 ppm chlorine. And the other major route of transmission of the disease is live feeds. I mean, we use live feeds in the maturation for these animals, which are imported from the breeding programs of US, which are SPF, we give live feeds. Live feeds we catch it from our wild, you know, the estuarine areas, and these are worms, then squid and all these things, polychaete worms, blood worms and all that. So these animals could be carrying a lot of diseases, the bacteria especially, and even EHP, because they're all coming from estuarine regions where there is some shrimp farming. So, though you are bringing in SPF animals into your maturation, you could infect these animals by giving this live feed. So, what we are doing is we pasteurize the live feed. We heat them to a level of 70 degrees. We put them in water and we heat them to 70 degrees. We don't boil them. If you boil them, the nutritional profile is changed. If you pasteurize them, the nutritional profile is not changed, it is intact, and you can get rid of all the pathogens. If you freeze them, you can control EHP, but completely get rid of EHP or other pathogens, it is advisable to pasteurize all the feeds that you take into the maturation. It could bring down your reproductive efficiency, but you are pretty sure that you are completely devoid of all the diseases that are contributing to the problems today. Or you can import frozen SPF polychaetes and you can feed your animals, but your fecundity levels are going to come down, your fertility of eggs is not going to be good, overall your reproductive performance is not going to be all that good. I mean, but pasteurization or pasteurized wet feeds is definitely helping the hatcheries to come up with seed that is free of all the diseases. If hatcheries don't do that way, they're going to pass on the diseases to the farmers. And the poor farmer who is taking the seed from the hatchery on blind fight, he is going to buy the disease also along with the feed. It's not just the seed, it's buying the disease. I mean, probably the hatchery is giving disease as bonus along with the seed. And hatcheries, other thing what they can do is they can do for modular operation and swift stocking. See, as we have discussed in the farming, if you're doing farming for longer length of time, the bacteria is increasing, the load is increasing. That's why you're trying to break it into 3, 4 stages. Likewise, hatcheries, if they go for very slow stocking and prolong the cycle, there is a chance for bacterial buildup. So you need to have modules, separate modules, go for modular operation, completely independent, and go for very swift stocking. If you have a module, stock it, try and stock it in one day, so that you have 4 modules, 4 days you stock. Whatever times you have, 4 days you stock, and it takes about 20 days for you to come to the PL stage to sell. So 4 days your stocking means 24 days. You can restrict the entire length of your cycle to 24 days. Thereby, you can reduce the bacterial load. So all these things are definitely required. These are kind of technical interventions that are required in the husbandry, in the farming and the hatchery as well. And the farmer could do it in the best possible manner. But if the hatchery guy is not following and trying to give the disease along with the seed, farmer is helpless. And antibiotics is also very, very important. You cannot use the antibiotics to be in line with the market requirement, because the market is looking at food safety. I mean, global markets require shrimp that is free of antibiotics. They don't want to see even a trace of antibiotic. They're talking about zero tolerance for antibiotics. One of the reasons why we are not able to export good quantities to Europe is because of that. Apart from that, if you're using antibiotics in the hatchery, it is going to affect your production, and it could make your bacterial population to go high. If you're using antibiotics, what happens is it's going to kill all the weak bacteria. The most pathogenic bacteria is going to stay back in the system, and then it starts proliferating. I mean, you all must have read competitive exclusion. It works on competitive exclusion. I mean, if there is no competition for this pathogenic bacteria, as all the weak bacteria has been killed by antibiotics. Whatever space you have, the entire space is taken by the pathogenic bacteria. It makes use of the resources that are available and proliferates further. So again, the hatchery guy is going to give the pathogenic bacteria to the farmer free. I mean, along with the seed is going to give this bacteria as a bonus. So hatcheries have to do away with antibiotics. Today there are processes through which one can produce good seed without uses of antibiotics. It can use probiotics and do away with antibiotics. It's going to help the hatchery guy to produce much more efficiently. At the same time, it helps the hatchery guy not to give bacterial bacterial inoculum to the farmers. I conclude here. I take little more than the time what the professor has given me, I think. But I conclude here saying that the farming and hatchery fraternities need to change and approach the operations differently to overcome the challenges the sector is faced with and be profitable again. I thank you, Professor, very much. I mean, for giving me this opportunity. I thank you and your university for giving me this opportunity to share my thoughts to your colleagues and students. I thank all the participants for the patient listening. I'm more than glad to answer any questions. You know,
Hello, students. I expect few questions from you. If students, please, before I discuss some things with Ravi sir, please come up with some questions. Students, the session is open for discussion. Uh, Amandeep, yes, you can ask. Please unmute Aman. Amandeep Kaur.
Yes, sir.
Aman.
Yes, sir.
Acha, it's you. Okay. You raise your hand. I thought you were asking something.
No, sir. I have.
Okay, fine. So any student? Any student? Any Jitendra? Any question? Chat box?
Yeah, looking, sir. Not yet, sir.
No. Okay.
They are clear about this stream because.
Yes. Okay. Ravi sir, it was a wonderful presentation.
thank you very much.
Frankly speaking, I even came to know about some new things about the industry. So as we have virtually met today, I would like to update you something about the shrimp farming in Punjab. Because I was expecting you to visit Punjab, but you couldn't. After this COVID, I am sure you are going to visit Punjab. So, university is playing an instrumental role in shrimp farming in Punjab. We got it introduced in 2014, and we are doing pretty well. And after coming back from industry, along with my few colleagues, we have one colleague here, and Dr. Shantanu, and all other colleagues, we tried to introduce Venami. Now, then it was one project was funded by state government of Punjab, and with technical support from our university and the Rohtak Center, Lali, that project, we got very good success. And now you will be surprised, we have reached about around 400 acres. As you told, as you told, I agree the fact that this EHP is not so much devastating in low saline cultures, because our farmers are somewhat culturing between 5 to 10, sometimes it reaches maximum 12, 13 during the because of this evaporation during the extreme summers. We just isolated one EHP from one pond, but we couldn't find much devastating it, although we see white fecal disease, and we are doing pretty well. And this year, you will be surprised that wonderful production our farmers have given one day. Although I could not go much into the field because of this COVID, but I was technically on phone, I was with them. We have got on an average more than 3.5 tons per acre, and they have reached even 30 count this year. One of my very progressive farmer, he harvested 82 tons from 22 acres.
Fantastic.
So we are
Fantastic.
very good. This year our farmers, because one thing more, we had one very low stocking density this time, maybe 30 or something like that. And I hope that we will be technically and coordinating in future on some, we'll be doing some collaborations with you, and we'll be needing your services in terms of good quality of seed. So it was a wonderful session, and hope our students have enjoyed the session along with my colleagues. And now I welcome one of my colleagues, Dr. Shantanu, to present
Sir,
a formal vote of thanks, please.
so there is one question in chat box from Manpreet
Okay.
Singh.
Yes. Manpreet, what is asking? What is sir's foremost advisors the advice for young students seeking entrepreneurship opportunities other than shrimp farming in Punjab or old states?
Oh, I mean, just now your professor has answered the question. He said, I mean, it is doing very well. Even I know it is doing very well in Punjab. And as you're going to take the bore water, definitely the culture is going to be very, very good. And there are a lot of areas which are saline and which are good for shrimp farming. Probably you can take shrimp farming definitely, and you have big cities around, so you don't need to even export. Also, you can sell the shrimp in the domestic market in metropolitan cities like Delhi and all that. Even in Punjab, you have Jalandhar, Ludhiana, and Amritsar. I think it's a very, very good enterprise to get into. And slowly you are having an ecosystem. You have a university which is going to help you in addressing the technical issues, and you have feed suppliers there, and a lot of us are going to be there. Definitely, I'm going to visit Punjab once the COVID goes down. We are very, very keen to be associated with shrimp farming of Punjab and with your university as well, Professor Prabhajit. And I think it's a very, very good option for the students to get into shrimp farming in Punjab.
Ravi sir, he's asking, other than shrimp farming, what can the young entrepreneurs do other than shrimp farming? What are the
I
other
mean,
opportunities?
other opportunity is definitely tilapia. I mean, tilapia culture has not taken up big way. I mean, if you look at the world and different countries, especially the countries of Indian economy. I mean, the countries wherein the economy is to the level of India's. I mean, tilapia is a big species in all these countries. Be it Brazil or Nigeria and all these countries. For some reason, tilapia has not caught up with Indian public at large, but definitely in future, tilapia is going to be one species that's going to do well. And you have a lot of freshwater bodies in Punjab, even the areas where the soil has become saline, tilapia can be done. I mean, tilapia, the salinities are also ideal, 5, 6, and all that. So tilapia is one thing that can be done, and these guys can, try to sell it online for the daily households and all that. New marketing tools are there, so definitely tilapia is another area, where they can try their hand.
Thank you. And Manpreet, let me update you one thing. You might have heard during the presentation, sir was telling about one very good thing. I totally agree with that. Since long we are using the same probiotic state, and not much work has been done whether these are effective or not. Why don't you take up your post graduation in AEM and work with some good
Yeah.
professors we have? And why don't you be with microbiota? Once you are done with that, you can venture into the shrimp, this medicine industry, and produce some of the good probiotics, and you can create a boom in the industry. We don't really have, we have probiotics. How efficient, what is the efficacy? Ravi, I have been talking long about this. We never know the efficacy
Correct.
of these probiotics, whether
True.
they're really working or not. And
Very true.
every now and then good companies are coming up, and it's it's an important aspect that we need to work on this, whether these probiotics are efficient. So Manpreet, it's a good opportunity for us. We can go venture into the this medicine industry. Any other question? Any students? Shantanu, I welcome my colleague Dr. Shantana Goda for a formal vote of thanks. Shantanu, please.
Thank you very much. Can you hear me?
Yes, very clearly.
Thank you. It was a nice presentation by Mr. Yalanki, sir. I heard your name a lot, but I have not seen it before. Thank you very much for coming up and sharing your excellent knowledge particularly with the students. First of all, I love to thank our university administrators, the Vice Chancellor, Dr. Indrajit Singh, and Dr. Meera D. Ansel, Dean College of Fisheries Science, and Dean College of Veterinary Science as well, who is the PI of the IDP cell under NAIGEP project. I love to thank all the administrators of the university on behalf of students of College of Fisheries and other participants. And today's speaker, it was a wonderful, nice, excellent presentation by Dr. Yalanki sir, who is leading Vaisakhi Biomarine Sciences Private Limited. This is one of the different topics or webinar we had today, particularly hatchery management and hatchery aspects. And you started your talk with many diseases which the industry is facing, and how you are managing those diseases and those challenges. It's really one of the highlights of the talk today. And we all, most of the time we talk about, we discuss about, we conduct trainings about farming practices, how the feed management need to be taken. But today you shared your knowledge about hatchery management, how you are facing the problems, what are the problems you are facing, and how you are managing those, and how you are coming out of those challenges. That's really one of the key points you discussed. And another thing is one of the important, particularly for students' point of view, we all focus in science, in research, we think about how to increase the growth of the species, whatever the species we culture. But you just today you open students' eyes so that they can think in different angles, particularly, not just focusing the growth of the species, but think about the tolerance of the species for any bacterial diseases or any pathogenic diseases. That's one of the lines or directions where students can really focus into. That's really interesting. And one of the innovative technologies where you are introducing, where people are introducing tilapia in cages in the shrimp farming. It is really interesting aspects where students can consider doing such sort of research to understand what exactly the mechanisms are involved, what exactly is the playing role in reducing the diseases. And throughout the your presentation, I understand you focused more into EHP and how to come out of these the problems, and the role of salinity playing in EHP, and these are all the things which we are really you enlightened us. Thank you very much for sharing your excellent knowledge. And as Dr. Prajit introduced, and during the conversation he discussed about your, that shows you have a great history of 25 years of experience in particularly shrimp hatchery industry. That's really highly appreciated. I thank you on behalf of students, coordinators and organizers, and university administrators. A great gratitude for you. Thank you very much, sir. And as Dr. Prajit has told,
pleasure is all mine, Professor Santanu.
Oh yeah, thank you very much. And we love to invite you after the COVID.
Definitely, I would love to come to your university and meet all of you. I would love
thank
to
you very much, sir, and thank you very much for your sweet words. Okay, throughout your conversation, very gentle and kind expression of your knowledge. That is also very key for a speaker. Sometimes we come across people know things, but delivering is different. But the way you delivered your lecture, it is highly it's very nice. Thank you very much for your
it's so nice of you to say that.
gesture.
Thank you.
And yeah, thank you very much. And I love to thank Dr. Prajit. He was since 15 days he was in constant communications and discussion with the speaker. It's not just organizing a webinar or whatever the events, but taking a suitable topic, and not only taking a suitable topic, but speaking or discussing with a relevant speaker. I think that's more important to make it a grand success, or not only making a grand success and sharing the knowledge to specifically with youngsters like our students. It is really great. Thank you, Dr. Prabhjit, on behalf of all the students and coordinators. All right. And I'd love to thank Dr. Vanith Indakar. She's one of the PA from College of Fisheries for under IDP, and unfortunately she's not there because of some other meetings. I thank on behalf of all the students. And I'd love to thank Dr. Jitendra and Dr. Amandeep Kaur, Senior Research Fellow, IDP Cell, for their significant contribution towards making this event for a smooth run. Okay, that's really one of the important aspects for a successful event for webinar. Thank you very much. And if I have forgotten anybody, I'm sincere apologies from my side, and congratulations to all of you. Thank you very much, sir. Dr. Pradesh, over to you.
Thank you, Shantanu. He has wonderfully, very nicely summed up the whole webinar. And Ravi sir, let me tell you, very recently I was undergoing one training program from NAM. So one speaker, he told what kind of 3 categories of speaker. So speaker, to be a very effective speaker, you don't have to be aggressive speaker. So you have to be a soft speaker. So you are one of a soft speaker. You speak very softly. You are not aggressive. You know, aggressive speakers are not always loud. Aggressive speakers, they just force their words on the audience. So as Dr. Shantanu highlighted, you're a very soft speaker. We loved your presentation. You spoke we didn't got bored also. Sometimes listening one and frankly speaking, it's sometimes boring. It was a wonderful, it was very wonderful and talk. Ravi sir, I thank you. I know how busy are you. I know that. I know that very well. You are associated with a big industry, and sparing time just on my single phone call, that shows your love for me. Thank you so much. And
always. It's gonna be there always, Professor.
Yes. And definitely we'll like to have you here. Once the code is here, we have a very good team. We are having one very good project from NFDB, Aquatics Disease Surveillance. Dr. Naveen is one of the scientists who is handling we are a team, and we are working very good. Dr. Shantanu was there while we introduced Vanami first time in Punjab in 2014 when we worked together, and we have a very good team, and you will visit our college definitely.
I would love to be associated with you.
Definitely we'll be collaborating, and thank you so much. And I think can we close the webinar now? I think
okay, that's fine. Thank you very much.
Thank you so much.
Friends, if you want, please do it so.
Please submit the forms, please, and only then you will get a participation certificate.